On November 13, while the world was still abuzz with a brand new series of images from Mars released by NASA, another more uncomfortable, thorny question suddenly arose. If they can get images from the red planet online so quickly, what's happening with the 3 Atlas photos that were taken on October 2 that are still missing? Already 45 days, the 3 images were taken by HiRISE, the highest resolution camera ever to orbit Mars, operated by a team from the University of Arizona. Given the time and processing power, the data should have been released long ago. The strange delay has not only intrigued the public, but has also raised questions: is something being delayed or kept secret? Asked directly if he believed the NASA administrator's explanation for the delay, Dr. Avi Loeb simply smiled calmly. He said he had no problem with that answer because the administrator was just repeating what he had heard, and so was Loeb. What he was looking for, he insisted, was simply truth. Loeb hopes that something will come out in the next few days. While he doesn't claim that NASA is deliberately covering up, he notes that the slow, bureaucratic nature of the system can easily lead the public to think otherwise, that there are many layers of information behind it that have never been spoken. The host nodded, repeating the key point that made everyone shiver. The photo was taken on October 2, but it was not released until November 13. The conversation ended with thanks and a promise to meet Dr. Avi Loeb again, the strange man who stands at the intersection of mainstream science and unsolved mysteries. A sudden and inexplicable change in the interstellar object 3. Atlas has put the astronomy community on high alert. In the latest set of observations, the object has begun to form a dust tail at an unusual rate, changing its structure more dramatically over the past few weeks than any existing models predicted. What began as a fuzzy, patchy streak has now accelerated into a sharp dust tail, captured in newly released high-resolution images, forcing research teams to reconsider basic assumptions about the behavior of interstellar objects almost simultaneously. A separate report appeared on radio astronomy networks. A short, unverified pulse recorded near 1,420 megahertz. The hydrogen line, a priority channel in deep space surveys and often monitored by programs searching for extraterrestrial signals. The discovery has yet to be independently confirmed, but the timing coincides with a period of increased Atlas activity, forcing scientists to scrutinize every bit of data, and will no doubt continue to fuel speculation and conspiracy theories surrounding one of the strangest objects to ever pass through the solar system. The situation continues to evolve rapidly, and any new updates are being closely monitored by researchers. 3I Atlas, the third interstellar object confirmed to have entered the solar system, has been closely monitored by telescopes around the world since its discovery. For months, it has behaved almost exactly as expected. Faint, slow-moving, and largely featureless, a cold, icy remnant from a distant star system, drifting quietly inward. But in recent weeks, Atlas's activity curve has begun to challenge all assumptions about how interstellar ice behaves in sunlight. The first sign of the anomaly came in the form of a column of material pointing directly at the sun, a rare behavior for comets in our solar system. Instead of developing a classic tail that extends away from the sun due to radiation pressure and solar wind, Atlas appears to be pushing material almost directly in the opposite direction, creating an asymmetrical, unbalanced, truncated structure that has left observers puzzled. Given the time and processing power, The data should have been released long ago. The strange delay has not only intrigued the public, but has also raised questions: is something being delayed or kept secret? Asked directly if he believed the NASA administrator's explanation for the delay, Dr. Avi Loeb simply smiled calmly. He said he had no problem with that answer because the administrator was just repeating what he had heard, and so was Loeb. A sudden and inexplicable change in the interstellar object 3. Atlas has put the astronomy community on high alert. In the latest set of observations, the object has begun to form a dust tail at an unusual rate, changing its structure more dramatically over the past few weeks than any existing models predicted. This is a puzzling exception to typical comet behavior, as most comets eject dust and gas in opposite directions under the influence of radiation pressure. 3I Atlas is different. It produces a dense, blunt jet that appears to be growing toward the light source. This strange emission pattern suggests that the material may be escaping from a local vent or a deep fissure in the stellar core, but the reason for the counter-rotating jet remains unclear. Remarkably, this gas flow has remained constant over multiple observation periods, without expanding or changing rapidly, remaining almost fixed in a structure that defies the normal dynamics of a comet. This unusual stability has increasingly puzzled 3I Atlas. Is it simply a strange outgassing phenomenon due to its surface shape, or does it reveal a deeper mechanism that has yet to be documented? While research teams continue to analyze the data, bold speculations have emerged in the astronomical community, contributing to the mystery of this interstellar visitor and making it worth keeping a close eye on. Then, almost in a stunning moment, the entire structure of 3I Atlas changed. New data from large aperture telescopes in the southern hemisphere, particularly from observatories in Chile and South Africa, showed that the once sunward jet had reorganized into a more familiar cometary tail, a long, well-defined streak extending away from the sun in a manner consistent with classical comet dynamics. What stunned astronomers about 3I Atlas wasn't just that its shape was changing in an unexpected way, but also that it was changing at such an incredible speed that it made many experts sit up straight and look at the data. In such a short period of time, its structure changed so dramatically that it looked as if some force had ripped material from the comet's core almost simultaneously. Initial photometric and spectroscopic analyses made the situation even more bizarre. Instead of the ultrafine, micron-sized dust particles typically found in solar system comets, the Atlas dust consisted of unusually large particles, as large as 1/10 of a millimeter. It's the kind of particle that's heavy, hard to accelerate, and especially not found in such large quantities. But 3I Atlas is ejecting those heavy particles in a surprisingly steady, continuous stream at speeds of just a few meters per second. There are no signs of collisions, no violent explosions like comets do when their surface ice sublimates. Instead, there's a slow, disciplined, almost deliberate pattern of ejection. This suggests that the core of 3I Atlas isn't just a jumble of ice, but maybe denser, more cohesive, even layered, with each layer reacting differently to sunlight. And that has scientists wondering, is this just a strange, icy object from far away, or evidence of a physical mechanism we've never seen before in our solar system? Things got even more confusing when spectroscopic measurements showed that gas from 3I Atlas began sublimating when it was 5 AU from the sun, too far away for any form of water ice to evaporate Only super volatile substances like carbon monoxide or carbon dioxide could undergo such a phase transition at such cold conditions. The fact that they appeared so early and so strongly suggests that Atlas contains a rich supply of volatiles similar to those born at the icy edge of a star system, a place so cold it's been near absolute zero for billions of years. This is exactly the kind of region where our solar system has its Oort and Kuiper belts, but the data show that 3I Atlas wasn't ours. It came from somewhere else, from far away. Features like the sun-facing jet and the expanding dust tail behind it were already scientifically significant enough to attract the research community's interest, but that interest took an unusual turn when word spread that radio observation networks had picked up a strange pulsing pattern near the 1,420 megahertz hydrogen line. Not only is this a particularly quiet frequency in radio space, low in interference and ideal for delicate measurements, but is also the frequency SETI has long considered the standard channel for any extraterrestrial civilization that really wants to be found. In the world of radio research, 1,420 megahertz isn't a random number. It's the place a civilization with a purpose would choose to send a message. The coincidence of the strange fluctuations of 3I Atlas and the appearance of radio pulses in the exact frequency range considered sacred in the world of extraterrestrial intelligence has many scientists, even the most skeptical, following every new data that comes in. They cannot confirm anything, but they cannot ignore it either, because in science, and especially in the stories that Americans always crave, anomalies are never simply anomalies. They're often the door to discoveries we have never understood, or truths that perhaps no one is ready to admit. The reported radio pulse lasted only a few moments and has only been recorded by a handful of independent observers. None of the data has been verified by scientific teams, and it is likely to be technical noise, a signal from Earth, or an unrelated phenomenon. However, the pulse's appearance coincided with a surge of activity in 3I Atlas, prompting several radio observatories to scan the area for repeats. A key factor in determining its true origin. So far, there is no evidence that 3I Atlas is the source. However, telescopes continue to monitor the 1,420 megahertz frequency, because transient signals sometimes open up new research directions, especially since comets rarely emit radiation beyond the familiar molecular lines. Meanwhile, 3I Atlas itself is changing rapidly. The comet's tail is growing longer, and its shape and brightness are changing, suggesting that its nucleus may contain multiple independent active regions. These observations provide a rare opportunity to study how an icy interstellar object reacts when heated. As it approaches the Sun, Atlas may develop stronger gases, a fractured surface, and new dust bands, all of which could provide valuable information about its structure and history. Compared to the two previous interstellar objects, the bizarre Oumuamua and the relatively normal Borisov, 3I Atlas exhibits distinct differences: large dust masses, rapid changes, and unique gas behavior. This makes 3I Atlas one of the most important interstellar objects ever observed. Scientists are gathering data urgently because of the possibility that the comet will fragment as it approaches the Sun, an event that could both destroy its original structure and reveal the deepest layers of material that have wandered between the stars for millions of years. Observatories on multiple continents are working closely together to monitor 3I Atlas almost continuously. Each type of telescope contributes a key piece of data. Optical telescopes record changes in brightness and the shape of the comet's tail. Infrared telescopes pinpoint hot regions where sublimation is most active, and spectroscopy helps identify the supervolatile molecules characteristic of the interstellar medium. Meanwhile, radio telescopes continue to search for rare molecular emissions and any unusual signals that coincide with increased Atlas activity, creating a rare radio archive for an interstellar comet. When these data sources are combined, scientists expect to create the most detailed profile ever of an interstellar object, far surpassing even the level of analysis available for 2I Borisov. If Oumuamua raises questions and Borisov provides a benchmark, then 3, iAtlas could be key to understanding the diversity of objects from beyond the solar system. The growing wealth of data will allow for reconstructions of how 3I Atlas sheds dust and gas over time. Changes in the comet's tail can reveal its rotation period, the location of active regions, and the structure of the coma, where the escaping gas interacts directly with radiation and solar wind. Even small changes in brightness can indicate that the comet's nucleus is elongating, becoming asymmetrical, or starting to break apart. These observations are particularly important because 3I Atlas represents a type of object that was kicked out of its parent star system and spent millions of years wandering through the galaxy. During that journey, its surface was eroded, its composition changed, and its internal structure reshaped by countless microcollisions. As it entered a new star system, the thermal shock from the strange radiation could trigger behaviors never before observed in the solar system, providing a unique opportunity to study the evolutionary history of icy matter throughout the galaxy. The scientific community is watching 3I Atlas with unprecedented attention. Whether the reported radio pulses are truly significant or just a technical glitch, the array of phenomena Atlas displays an unusually fast-moving dust tail, rare, large, and heavy dust grains, and an early acting layer of volatile material all point to a complex layered structure formed under conditions that science has yet to fully characterize. In the coming weeks, as Atlas 3I moves closer to the Sun, most experts expect its rate of change to accelerate. Jets may erupt from new cracks. Tail structures may shift or branch, and unexpected patterns of radiation from infrared to radio may appear. For scientists, it's a golden opportunity to observe a powerful interstellar object. But for the superpowers competing in the space race, Atlas means something else entirely. In the context of strategic competition, any strange signal or unusual behavior from Atlas is easily the focus of simmering speculation. Some commentators in the U.S. have questioned whether any countries are watching Atlas more closely than they publicly claim, or even hoping to exploit its data before their rivals. It has been suggested that if Atlas 3I were to produce a repeating signal, even if it were entirely natural, it could still be interpreted by intelligence agencies as strategic, as history has shown that any anomaly in space is likely to be interpreted competitively. Some more skeptical observers have suggested that if Atlas suddenly changes orbit due to a powerful outgassing, the change could be closely monitored as a natural test for nations' early warning systems. In a world where space militarization is on the rise, nothing is too small to ignore. But all the theories aside, it's the scientific truth that matters most. A tiny, ancient traveler from a distant star system is revealing its past right before our eyes. In real time, every new image, every spectroscopic measurement, every tiny change in the stellar envelope brings us closer to understanding the universe through the eyes of an object that has been wandering among the stars for millions of years. Atlas is both a mystery and a scientific gift, and each change it makes could be a piece of a much larger story. The story of the origin of matter in the galaxy and our place in it. So don't forget to subscribe and turn on notifications so you don't miss the latest data on this historic moment in the universe.